Exercise 4.5 NCERT textbooks. Find the inverse of each of the matrices if exists given exercise 5 to 11. Question number 5. Given matrix is this. Now solution. For convenience, let A is equal to 2 minus 2 4 3. First, we have to find cofactors of all elements of the matrix. That is, A11 is equal to this row cancel and this column cancel. We get 3, that is positive. A12, that is 1 plus 2 equal to 3, so negative. This column cancel and this row cancel, then we get minus 4. Next, A21 is equal to 2 plus 1, 3, therefore negative. That is that element. This column cancel and this row cancel, we get minus 2, minus 2, minus 2, plus 2. Next, A22 is equal to positive 2 plus 2 4, so positive. Therefore this column cancel and this row cancel, we get 2. Now adjoint of A is equal to A11, A12, A21, A22 and their transpose. Now putting the values of A11, we get 3, this equal to minus 4, this equal to 2, this equal to 2. That is this. Now we interchanging rows and columns, then we get 3 minus 4 2 2. Since we know A inverse is equal to adjoint A by del A. Here we find del A is equal to A11 plus A12. This implies A11 is equal to 2. This is 3 plus A12 is minus 2 into A12 is equal to minus 4. Therefore, we get 6 plus 8 is equal to 14, not equal to 0. Therefore, A inverse exists. This implies 1 by delta is equal to 14 and adjoint is equal to 3, 2, minus 4, 2. That is the inverse of the given matrix. Now question number 6. Solution. For convenience, let A is equal to minus 1, 5, minus 3, 2. First, we have to find cofactors of the elements. Therefore, we get A11, that is positive. This row cancel, this column cancel, we get 2. And A12 that is negative, this row cancel, this column cancel, minus 3 minus minus plus 3. A21 is equal to negative, that is that element, this row can, this column cancel, this row cancel, we get 5. A22 that is positive, this column cancel, this row cancel, we get minus 1. Therefore, del A is equal to A11 A11 plus A12 A12, expanding by with the help of first row. Now putting the values of, that is minus 1 into 2 plus 5 into 3. This equal to 15 minus 2, so we get 13. Not equal to 0. Therefore, we can say A inverse exists. Now we have to find adjoint of A. Since adjoint of A is equal to A11, A12, A21, A22, their transpose. This equal to, we get 2 plus 3 minus 5 minus 1, their dash. This implies after interchanging rows and columns, we get 2, 3 minus 5 minus 1. Now A inverse is equal to, again since A inverse is equal to adjoint of A by del A. This implies 1 by del A is equal to 13. And adjoint A is equal to 2 minus 5, 3 minus 1. And that is the inverse of the given matrix of question number 6. Now question number 7. Solution. For convenience, let A is equal to 1, 2, 3, 0, 2, 4, 0, 0, 5. Now we have to find cofactors of all elements. Therefore, we get A11, this equal to this row cancel, this column cancel, we get 10, that is positive. Next, A12, that is negative. This row cancel, this row cancel, this column cancel, this row cancel, we get 0, therefore 0. A13, that is positive. This column cancel, this row cancel, this put on this, therefore we get 0. Next, A21, that is negative. Negative, this row cancel, this column cancel, therefore we get minus 10. A22, this is positive, therefore we get this goes and this goes, therefore we get only 5. Next, A23, that is negative, then we get this column cancel, this row cancel, we get minus 2 minus minus plus 2. Now A31, that is positive, that is this goes and this goes, therefore 4 minus 6, therefore 8 minus 6, therefore we get 2. A32, 2, that is negative. This column goes, this row goes, therefore we get minus 4, 0, therefore we get minus 4. Next, A 3, 3 positive, therefore we get this column cancel, this row cancel, therefore we get only 2. Now delt A is equal to, expanding with help of first row, we get A11, A11, A12, A12 plus A13, A13. This is equal to 1 into 10 plus 2 into 0 plus 3 into 0. This equal to 10. That means not equal to 0. Therefore, we can say A inverse exists. Now we have to find adjoint of A. Since adjoint of A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33, and their transpose. Now putting the values of the elements, we get A11 is equal to 10, A11 equal to 10, A12 is equal to 0, this is also 0, that is minus 10, this equal to 5, this equal to 2, this equal to 2, this equal to minus 4, this equal to 2, and they are transpose. Now we interchanging rows and columns, we get ten minus 10, 2, 0, 5 minus 4, 0, 2, 2. Therefore, A inverse equal to, we know adjoint of A by delt A. This implies 1 by delt A is equal to 10 into adjoint of A. Adjoint of A is 10 minus 10, 2, 0, 5 minus 4, 0, 2, 2. That is the inverse of the given matrix. Now question number 8. Solution. Let A is equal to the given matrix 1, 0, 0, 3, 3, 0, 5, 2, minus 1. First, we have to find the cofactor of the all elements. Therefore, we get A11, that is positive, this goes and this goes, minus 3, 0, therefore minus 3. A12, that is negative, this goes and this goes, therefore we get minus 3, 0, therefore it is plus 3. A13, that is positive, then we get this goes, therefore 6 minus 15, 13, therefore minus 9. Next, a2, 1, that is negative. This goes and this goes, therefore we get 0, therefore 0. A2, 2, that is positive. This goes and this goes, that is minus 1, minus 0, therefore minus 1. Next, a2, 3 is equal to, that is minus, therefore this column goes, this row goes, therefore 2 minus 0, therefore minus 2. Next, a3, 1 is positive, therefore this column goes and this row goes, therefore 0 minus 0, we get 0. a3, 2, that is negative. This column goes and this row goes, then we get 0 minus 0, therefore 0. a3, 3, that is positive. This column goes, this row goes, therefore we get 3 minus 0, therefore this goes and this goes, therefore 3 minus 0, therefore we get 3. Now we have to find delta A. Therefore, delta A, expanding with respect to first row, we get A11, A11 plus A12, A12 plus A13, A13. Now putting the values up, we get 1 into minus 3 plus 0 into 13 plus 0 into minus 9. This equal to minus 3, not equal to 0. So we can say that, so we can say that A inverse exists. Now we have to find the adjoint of A. Therefore, ADJ of A, adjoint of A, is equal to, we know, A11, A12, A13, A21, A22, A23, A31, A32, A33, and their transpose. Now putting the values of cofactors, we get minus 3 plus 3 minus 9, 0 minus 1 minus 2, 0 0 plus 3, and their transpose. Next, now we are intersecting rows and columns. We get minus 3 plus 3 minus 9, 0 minus 1 minus 2, 0 0 3. That is the adjoint of A. Since we know, since A inverse is equal to adjoint of A by delta A, this implies 1 by delta is equal to minus 3, and adjoint of A, that is minus 3, 0 0 3 minus 1 0 minus 9 minus 2 3. That is the inverse of given matrix. Now we can write in this way also. After multiplying minus 1, then we get, that is the plus 3, 0, 0, that is minus 3, 1, 0, that is 9, 2, 3. Sorry, this is actually minus 3. Now question number 9. Solution. Let A is equal to the given matrix 2, 1, 3, 4, minus 1, 0, minus 7, 2, 1. First, we have to find the cofactors of the all elements. Therefore, A1, 1, that is positive, this goes and this column goes minus 1. So, we get minus 1. A1, 2, that is negative. Therefore, this goes and this goes, we get minus 4. A1, 3, that is positive. This column goes and this row goes. Then we get 8 minus 7. Therefore, we get 1. Now, A2, 1, that is negative. Then this row cancel and this column cancel. We get 1 minus 6. That is minus 5 and minus, therefore plus 5. A2, 2, that is positive. Therefore, we get this column cancel and this row cancel. We get 2 plus 21. Therefore, we get 23. Next, A2, 3. This implies minus this column goes and this row goes. Then we get 4 plus 7, that is minus 11. Therefore, 11. Next, A3, 1, that is positive. This goes and this goes, this 0 minus plus 3. A3, 2, this equal to negative. Negative, therefore this column goes and this row goes. We get 0 minus 12. Therefore plus 12. A3, 3, that is positive. This column goes and this row goes minus 2, minus 4, therefore minus 6. Now we find del A expanding with respect to first row. Then we get A11, A1, 1 plus A12, A12 plus A13, A13. Now putting the values, we get 2 into minus 1 plus 1 into minus 4 plus 3 into 1 is equal to minus 2, minus 4, minus 6 plus 3. Therefore, we get minus 3, which is not equal to 0. Therefore, A inverse exists. Inverse exists. Now, we find adjoint A. According to adjoint definitions, we get A11, A12, A13, A21, A22, A23, A31, A32, A33, 3 and their transpose. This can be written as by putting the values we get -1, -4, 1, 5, 23, -11, 3, 12, -6 and their transpose. After interchanging rows and columns, we get -1, -4, 1, 5, 23, -11, 3, 12, -6. That is the adjoint of A. Now, since A inverse is equal to adjoint of A by del A. 1 by, since del T is equal to -3. Then adjoint of A is equal to -1, 5, 3, -4, 23, 12, 1, -11, -6. That is the inverse of the question number 9. Question number 2. Now question number 11. Solution. Solutions. Let A is equal to the given matrix 1, 0, 0, 0, cos alpha, sin alpha, 0, sin alpha minus cos alpha. First, we have to find the cofactors of all elements. Therefore, we get A11. This row goes, this column goes, therefore we get cos square minus cos square minus sin square minus common, therefore we get -1. A12, this row column goes, this row goes, 0 minus 0, therefore we get 0. A13, that is positive, this column goes, this row goes, this put on this 0, this put on this 0, therefore we get 0. A21, that is negative, that is this row goes and this column goes, 0 minus 0, therefore we get 0. A22, this column goes and this row goes, then we get minus cos alpha minus 0, therefore minus cos alpha. A23 is equal to negative. Actually, this row goes and this column goes, therefore we get 0 minus 0, therefore we get this row goes and this column, this row goes, this column goes, minus cos alpha minus minus plus cos alpha. 2, 3, therefore this goes and this goes, therefore minus sin alpha, not cos alpha, sin alpha, that is negative, minus sin alpha. Next, A31, that is positive, that means this row goes and this column goes, 0 minus 0, therefore we get 0. A32, that is negative, this goes and this goes, therefore minus sin alpha, therefore minus sin alpha. A34, 3. That is positive. This row column goes, this row goes, therefore cos alpha. Now del A is equal to del A is equal to expanding with respect to first row A11, A11, A12, A12, A13, A13. This equal to 1 into minus 1 plus 0 into 0 plus 0 into 0. This equal to minus 1, not equal to 0. Therefore, we can say A inverse exists. Now we have to find adjoint A. Since ADJ of A adjoint A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33, and they are transpose. Now putting the values of the cofactors, we get minus 1, 0, 0, 0 minus cos alpha minus sin alpha, 0 minus sin alpha cos alpha, and their dash, that is transpose. This is equal to, after interchanging rows and columns, we get minus 1, 0, 0. Next 0 minus cos alpha minus sin alpha. Here 0 minus sin alpha cos alpha. That is the adjoint A. Now A inverse is equal to, we know adjoint of A by del A. This implies 1 by del A is equal to minus 1 into adjoint of A. Adjoint of A is equal to minus 1, 0, 0, 0 minus cos alpha minus sin alpha, 0 minus sin alpha in cos alpha. Now we multiply it by minus 1, then we get the result. Therefore, we get 1, 0, 0, 0 cos alpha sin alpha, 0 sin alpha minus cos alpha. That is the inverse of the given matrix of the question number 11. Thank you.